Rajagopalan. Good luck, my friend.
Thank you. Hello, everyone.
I know Raja.
Let's do this. So I'm going to quickly introduce Accelerite to you because I'm sure very few of you have heard that name. So let me just take 1 minute to just talk about who we are, then we'll get into the topic itself. So Accelerite is a company that didn't exist 4 years ago. We're sort of a new kid in the block. What we did was, we built the company using what we call assets. We buy software assets from large companies that we like, that we think has lots of legs. And we've done acquisitions from Intel, Citrix, HP, OpenWave, et cetera, and a few small startups, and we're using that. And then, we take that to market, and we invest and grow. We today have 4 different product lines. One is cloud infrastructure. Recently, we acquired a cloud platform. The Citrix is the Apache Cloud Stack distribution. Then a real-time security product that we evolved out of an acquisition we did from HP. Shared Insights is a homegrown end-to-end analytics product, and Epona is an acquisition we did from Intel. So there's an IoT platform. So that's a quick little introduction about us, so the name sort of sticks in your mind in the future. So what I really want to talk about is the state of cloud today, right? I mean, if you just look at what is happening in the market, all of you have developers in your company. Just a quick show of hands. How many of your people in your companies use Amazon, Azure, IBM SoftLayer, BT, Cable and Wireless, some public cloud? Several hands went up. Just out of curiosity, how many of you have a true private cloud running? Okay, far, far fewer hands that went up. People talk about a huge cloud market, and it is big today, but almost all of it is being spent on public clouds. The concept of a private cloud doesn't exist. Now, VMware does make a lot of money, and that largely is being made out of what I would call, is there a way to go back? Virtualization market, right? So if there is an enterprise developer in your company, the likelihood is they are directly going to Amazon. Most likely Amazon as a first choice, perhaps Azure as a second choice of Microsoft shop. And they are using their tools, their cloud, in order to get their stuff developed and deployed. And that is, almost all of the market today. There are several other, public clouds available. IBM has SoftLayer, which is a very competent, with their Bluemix platform, a very good cloud. Several of our customers today run public clouds based on our infrastructure. But, largely the concept of private clouds are, non-existent today. And virtualization is where the enterprise IT spend today is. I mean, this is basically, your standard VMware or KVM or Xen running, and enterprise workloads such as CRM, ERP, whatever it is, HRM, running directly on it, but that's not a cloud. So fundamentally what we call a cloud versus virtualization is if you're running VMs, it's a virtualized environment, but it's not on tap. Your developer is not able to use an API, spin up a VM, spin down a VM, do DevOps, CI, CD, scale up, scale out, et cetera. They're not able to do that. They have to call IT and say, I need 5 VMs. This is the size I want. IT provisions it for you. And you go and deploy your workload on it. That's virtualization. That's not cloud. You want really an API different cloud. Now, if you just look at the market, though, you would see that there is a terrific amount of spend on still physical data centers owned by enterprises. So it is not that just because the public cloud is there, all the work is going to go there. If there was a competent private cloud available within an enterprise, there would be a definite need for it. I'll tell you drivers for something like that. I mean, one of the needs would be cost. In scale, and we have done math somewhere based on what kind of stuff you buy, et cetera, somewhere between 50 and 80 VMs worth of workloads, it starts becoming more economical to run the workloads on-prem than on public cloud. Again, it depends a lot on your operational efficiencies, et cetera, but in general, that sort of is a break-even point. So if you have a large workload, certainly economically speaking, it might start making sense to run your workloads on-prem. Other than that, there is regulatory reasons. There is just sunk cost. There are people with tons of data centers sitting there, and if possible, they would rather use that than go out. So there is a lot of reasons why there would, just in the morning session, I forget, I think it was the IBM folks who mentioned that, 55% of the workloads are never expected to move out of enterprises into the public cloud. I think it's even a conservative projection. If you just look at bare metal spend today versus cloud, bare metal outstrips the cloud spend by 5 to 6x. So the market is always going to be there. The question really is it possible to run a private cloud that is as good as a public cloud? Let's take an example of an application. Today's conference has been a lot about IoT. People have spoken about IoT quite a bit. Let's actually take an IoT application out and see what it takes to build an IoT application. And let's then think about even the choices of private clouds that are available today, would they suffice, right? Even if we're able to take an OpenStack deployment or CloudStack deployment or vRealize or something like that and take it and run a cloud today, even if it was extremely easy, forget 0 to cloud in 60 minutes or anything like that, even if it took you 15 days or 30 days or 60 days to run it, would that be enough to meet your developer's need? Let's take a look at that. So if I were a developer and I was developing an IoT application, and let's take a typical IoT application. What I might want to do is, it's a connected world. There are tons of connected devices, sensors, whatever. You want to be able to sense what is happening out there, right? That is the first thing. You want to sense what is happening out there. And you want to be able to respond to those events right away. In other words, you don't want to take it all the way and do a whole bunch of stuff, but something happens, you need an immediate response to that. So in other words, something, and boom, this is the response that is there for that. That is the obvious, immediate thing you got to do. And you got to be able to do this in scale. When you're talking to millions of connected devices, there is like tens of millions of events a day. You have to be able to process events at that speed. Then you want to be able to store the events. You want to take all those events and store it because it might be for logging, it might be for learning, it might be for reporting. There might be a variety of purposes why you want to store these events. The next obvious things to do is analyze and learn, right? You want to be able to analyze these events and find out what's going on and perhaps run some machine learning algorithms to figure out, okay, here was the event that happened, this is the response that worked versus not worked, and how do I now program my machine to sort of learn by itself as to what the right responses are. Then based on your learnings, you devise a control system that basically responds to things the right way and then program it the right way so that the right responses are built into the control systems rather than a one-off event. And finally, you want to be able to present this data to the user. So if you think about it, if you took all of this and wanted to build this on what's available today, even in a private cloud setting, and forget Amazon, Azure, even IBM with Bluemix, these are pretty advanced clouds, but let's just look at what options are available in the private cloud. So the anatomy of a cloud application that I just mentioned, if you just tried to build this on infrastructure as a service, and when we say infrastructure as a service, we define this as compute, storage, and network. That is the core stuff that you get if you run an IaaS cloud, right? If you just took that and tried to do it, this is like just a skeleton. Instead of a human being, this is just a skeleton. This is bare bones infrastructure, which you can do whatever you want with it, but there is very little in it of itself. And the difference between a skeleton and a human being is quite a bit. What is lacking? What is lacking is the fundamental things that happen in our body. Your sensors are feeling what is happening out there in the world, and the nerves are taking that and connecting it to your spinal cord, where the immediate response is happening at, again, millions of events a second. Anything that, you touch a fire and your finger retracts and the brain didn't respond to that. Something very, very locally responded right off your spinal cord, right? And then it went to the brain and it gets stored and gets processed and it gets analyzed, and you're learning that, okay, if I touch a hot thing, it's going to burn me. Let me not touch that hot thing again, right? And then you store it, and then, over a period of time, you learn how to behave, right? So eventually, the application, which is exposed using APIs, all of this learning, all of this data is exposed through APIs, and eventually you take that APIs and you build an application on top of that. That is your typical anatomy of a cloud application, right? Now, this cloud application, if you just break it down to what is needed in order to build it, just what is available in a private cloud, such as compute, storage, network, that's not going to cut it. You need much more than that. So the basic thing of all these sensors are out there getting data and throwing events at me. You need to be able to have a very, very competent publish-subscribe bus. Now, Kafka is becoming sort of a well-accepted standard out there among developers, saying that, look, events are being published by the real world, applications are subscribing to them, it's happening at millions of events a second. I have to be able to just move this data across my network into where it can be processed. That today's, Kafka is getting a lot of traction in that particular space. Then you want to be able to process your spinal cord, which says that, boom, an event came in, here is my response. How do I process millions of events that is happening immediately? So Spark streaming is getting a lot of traction today. And if you were a developer, just those two pieces, being able to deploy that in scale is going to be hard. It is not easy to take Kafka or Spark and be able to run it in a scalable fashion. So if you were running a private cloud, if you were IT, and if you were running a private cloud and you offered just basic compute and storage, your developers now have to figure out how to run Kafka, how to run Spark, how to scale it up, how to scale it out, how to do disaster recovery for it. All of that stuff is pretty complex instead of just being able to run just a scalable compute infrastructure. Next, they have to be able to store it and analyze it. That brings to bear how am I going to store it? Today I can go to Amazon, I can get RDS, I can get DynamoDB. RDS is a relational database as a service. Dynamo is sort of NoSQL as a service. I'm able to store millions of events that come in at a very, very scalable fashion and be able to offer that to my developers where they can consume that service without having to worry about how do I scale this up, how do I scale this out, et cetera. So that is another big challenge. So how do you now offer database as a service or Hadoop as a service, which is analytics, right? At the end of the day, you're storing all these millions of events, and you want to be able to process them in a scalable fashion and be able to learn from them. You got to be able to run machine learning algorithms on it. And finally, you have to be able to do things. Gone are the days of monolithic large programs, right? I mean, until 2-3 years ago, developers wrote these monolithic programs, which were large web server-based things, where I wrote code and stuff came in, and I was doing everything in this one large application. Those days are gone. Microservices, the concept was introduced, and they're on fire today. They're on fire. I mean, containers are the foundation of microservice. Amazon launched a service called Lambda, and it's really taken off. I mean, tons of people are now using Lambda, and it basically says that you're not writing a large program anymore. You're writing tiny little code, right? It's serverless programming, they call it. You write small pieces of code and respond to whatever is happening. You could respond to a simple API, you could respond to a single event response, et cetera. Tiny little pieces of code and throw it in. You don't know what's running. Your entire application is not scaling. These little pieces of code are scaling, which is the fundamental building block for that is containers, right? You're basically taking your workload, making everything into a container, into tiny little things, and letting them sort of scale up and down based on only if one API is getting called 1 million times, only that piece of code runs a lot of times. I mean, I know companies today which are running web services as a service, and believe it or not, they shut everything down. There is nothing going on, right? There are no VMs running, web servers waiting for somebody to come. Everything is shut down. Everything is containerized. When I go to www.blahcompany.com, the container kicks up, and it immediately pulls up the web page, and I respond. So as an infrastructure provider, they're able to save millions of dollars by not having to run everything at all the times. Everything is shut down. Things come up. Things go down. It's very, very dynamic, right? So here is next generation infrastructure that is going to be needed by your developers. If you, as an IT organization, or if you were a cloud service provider, if you wanted to offer something that competes with the Amazons of the world, you have to be able to offer something as competent as that, as complete as that, for your developers, your customers' developers, whatever it is, if you want it to truly be an alternative. So what are the challenges in doing this today? So, if you all agree that, look, yeah, private clouds make sense. Private clouds are economical. private clouds are, I don't know if I can claim they're more secure, but if you go talk to a bank, they're going to say that I don't trust public clouds. A lot of banks still say that. How much ever public clouds shore up their security, they're still going to say that, I just prefer private clouds because it's close to me and I have more control over it and passing regulations is easy. I don't have to worry about going to 10 different vendors and ensuring that they're compliant to all these regulatory needs of mine, et cetera. So there are going to be lots of reasons why this is needed. So if we all agree that, look, private cloud is a need and it is economical, it is secure, it gives me a sense of security, and if you want to do it, first challenge today is it's hard to deploy, right? Those who have deployed it, you can go and ask them. It took them months to do it. It did not take them days. It did not take them weeks. It took them months to do it because it is complex stuff to install. Depending on what you choose, the user experience is not as good. The APIs might be there, but the user experience for the end user is not as good as what is available in public clouds. So, if we're going to compete head-to-head with the public clouds of the world, you have to be able to offer an alternative that is as good. So, as I said, all experiences are not as smooth as a public cloud, and not enough services. So even if you stood up a private cloud, you want to be able to think of, database as a service, Hadoop as a service, Spark as a service, continuous integration and continuous deployment tools. You want to be able to think all of those things and offer those to your developers. Otherwise, they're not going to consume it. They would still prefer going to Amazon rather than your private cloud until your cloud is complete enough to meet their needs. Not enough expertise to run a cloud. If I don't know how many of you are in enterprise IT organizations, but most of the enterprise IT organizations I talk to find running a private cloud a daunting task. Because running a cloud is not just best practices, it is knowledge of the specific tools, trying to understand when to scale it up, when to scale it down, what is a cost model, is there a way for me to somehow burst into a cloud rather than having to, let's say that 80% of the time you're running at 40% workload, but the short amount of time that your workloads expand, is there a way to seamlessly burst into a public cloud rather than keep everything local, et cetera? These are all real challenges, and you have to be able to deal with answering these questions and designing a cloud that can give you all this flexibility, and that is not an easy problem to solve, definitely. Unpredictable ROI. This is something that I talk to CIOs all the time, and this is something that I hear constantly, right? We are not able to convince the organization that this is going to make sense, this is going to save money. It's very, very unclear what the ROI is. And finally, there is tons of trust issues between IT and developers. Developers love Amazon. They feel that this is perfect, I can just go, buy whatever I want, use whatever I want. And I've never had anything other than virtual machines from my IT. Why do I trust them? So that is another key question you have to solve. So all of these challenges exist, and it is hard to get a private cloud deployment going in an enterprise primarily because of this. So let's look at the players, right? So the major providers, Amazon, Azure, to some extent IBM, they're next door to me, so I can't say not at all IBM, so definitely to some extent IBM. These are all very, very good private clouds. I don't know how much, developers directly go and use these one versus the other, but definitely very competent public clouds. There are several CSP clouds, and a lot of them are our customers today. They are probably the second today. They're increasingly offering better and better services. Private clouds are still very hard to deploy, very, very nascent. And if it is just pure virtualization, that hasn't even begun running yet. That doesn't solve the problem. So what is the need of the hour? Pre-integrated high-level services. It is not just infrastructure as a service, but you want to be able to solve higher-level challenges. You want to make sure that your cloud doesn't have a vendor lock-in. In other words, there are multiple approaches to the world today, but there might be a little bit of self-serving attitude here because ours is not locked in and others might be, et cetera. But then we chose our approach towards this in order to make sure there was no lock-in. But definitely you don't want a vendor lock-in. There are several approaches in the market today. You could go and buy hyper-converged, and it does give you at least infrastructure as a service on tap like that, but then you're locked in for the vendor for the rest of your life. Every compute, every storage node you're buying from them for the rest of your life. There is a lock-in there. And you want it to be a stable platform. It's got to be something which is rock solid. You have to be able to upgrade from one version of the cloud to another seamlessly. Today on Amazon, used to be 4 years ago, 5 years ago, when I ran workloads on Amazon and I had to upgrade from, migrate from one to the other, there was a lot of disruption in the service. I would get emails 5, 6 years ago from Amazon saying that the machine on which your workload is running is bad, and I need a downtime so that I can migrate your workload from one to the other. I mean, gone are those days. Today, everything migrates very, very seamlessly, and traffic is running, and they're upgrading their cloud from one version to the other constantly. Good luck with that if you're running a private cloud today, because if you want to upgrade your cloud, there is definitely a downtime, not just for the cloud, but all the workloads that is running in it as well. Right? It's got to be intuitive to operate and consume. You got to be able to deploy it in minutes. I mean, this is something that we pride ourselves in doing, but I think that is going to be a need. And a cost model that is, again, for ROI, it should be important that the cost model is consumption-based and not capital expenses-based, because it's very hard for enterprises to justify capital expense. But if you can do this, this would be a great advantage. Ideally, it should be open source. There's nothing wrong with closed source, but open source gives a sense of security for everyone, saying that this is something where the vendor goes away, the product is still going to exist, and all the typical stuff. I think there's a lot to be said about that. And if there was an option to be fully managed, so if you don't have within your IT organization the expertise to run a cloud, ideally you should be able to get it from somebody else who can stand up a cloud for you and run it. So that would be the ideal situation. Now, if this were available, I think private clouds can be deployed. For a moment, I'm just going to stop and see if there are any questions, because the next slide is going to be, again, a little self-serving. But until this point in time, I'll try to keep it fairly neutral to just say that what the challenges that are faced by the world are, et cetera. Any questions at this time before we talk about what we do? So we have created a product called, yeah, sorry, go ahead. Yes, in fact, yes, I take it back. IBM has had an infrastructure as a service private cloud for a long time. But again, I think the point I was trying to make was everything else, Spark as a service, Hadoop as a service in a private environment that I can get off the shelf, rather than having to integrate things by myself, was the point I was trying to make.
Well, it's also a platform as a service, and you can run non-IBM software on it and make patterns on it.
Absolutely. Again, PaaS is, I'm not talking PaaS. If I were to take PaaS, and if I had to design my own anything as a service, that is absolutely a choice that is out there today. I could go get Cloud Foundry, and I could spend the time, I could take IBM's, product as well. I can certainly spend the time and do it. I put IBM up there in terms of private cloud capabilities, because IBM is among the best choices out there. I'm guessing you're from IBM, but I have a lot of respect for IBM's ability to do this. Again, it's not. IBM's approach is stopped at infrastructure as a service and giving you the tools to do the rest of the stuff. And I think the need is not just stop there, but truly have the pre-integrated higher level services. So if I have to take a PaaS, I don't know how many of you have tried deploying Cloud Foundry and running a PaaS on top of that. Cloud Foundry's got lines of people who helps you do that. Pivotal's got people. So it's not an easy challenge to solve. So if you think taking a PaaS and being able to design your own anything as a service on top of that and running it, it is a hard problem to solve. And I think the need of the hour is, that is a great first step, absolutely agreed. But I think more and more of these things that come pre-integrated, that I think is what the market needs. I'm not claiming that we have it, but I'm just saying that if there was a need, it should be for pre-integrated high-level services which can scale up and scale out, which IT departments don't have to worry about. The problem with the clouds has been the challenge of it is hard. And if I have to take Cloud Foundry, and if I have to figure out how to run anything as a service on top of that, and that is what is being asked of an IT department to do this, we are setting them for a failure, because it's hard work to do. So that's way too many clicks. Oh, I'm going on backwards, no wonder. Sorry. Again, way too many clicks. I'm really sorry. Here, but I have 5 minutes. I can click the button for 5 more. There, I'm back. So what we offer is either an appliance form factor or a software, but essentially we offer a prepackaged solution that you can just download and install. It is based on an open architecture, which means that you can bring your own compute nodes, you can bring your own storage nodes. There is no lock-in with us. All we sell is the brains of the cloud. So we allow you to just rack up the brains of the cloud with any compute, any storage of your choice, bring it up, and then there are check boxes you can pick, give standard configuration, and the cloud boots. And it's based on Apache Cloud Stack, not OpenStack, which, I suppose disadvantage-wise, it doesn't have all the momentum in the world, but advantage-wise, it's rock solid. Very, very stable, runs very large public clouds today. It's based on an open source architecture. Now, PaaS is something we're working on, as rightly pointed out, something that you will need. So not for basic stuff. I don't think you should depend on a PaaS to run basic things. I think containers should be off the bat. Microservices, infrastructure should be built in. Database as a service should be built in. Hadoop as a service should be built in. Spark as a service should be built in. If you're offering a custom application that you want to do something with, go ahead, use PaaS or use Kubernetes or whatever you have that we have prepackaged in order to get those in a scalable fashion, scaled out and deployed. But the fundamental things your developer needs that Amazon offers off the shelf, we believe should be packaged into a private cloud, and that is what we do. And something that boots in minutes and upgrades in minutes. So again, the challenge, and there should be absolutely zero downtime in traffic. If you want to upgrade your cloud from one version to the other, the cloud should just keep running, and the software that controls the cloud should just upgrade itself. It should be fully managed, and as an option to fully manage, that's scale up, scale down, as well as scale out cloud. So that is what we think the right answer for the market's need is. And we are beginning down this path of offering it. We are probably somewhat there. We don't have the PaaS. We don't have some of the high-level services we would like to offer. But we have set out on a path to solve the problem the way we see it should be solved. Anyway, so that's us. We have a booth right outside when you walk in next to IBM. So please stop by and see what we got going. Thank you.